Hey guys, welcome back to another Y-Coder video. This video is going to be a little different as I've started a YouTube series named RoBo Tech, and welcome to the first episode. As you guys know, the pandemic did not settle and we are still forced to be in our home. I guess this is the best time to learn something new, and one of them is robotics. I would like to start from the very basic, that is building a simple RC car using a QtPy kit and programming it through code blocks. As we move on, we can go to the advanced levels. And yes, let's get started. We require a motherboard, two DC motors, and two wheels, along with some building blocks. In order to hold the motherboard in place, we can build something like a nice cage. Connect two DC motors along with the tires in the opposite sides, and connect the left DC motor cable to port 1 and the right motor to port 2. It would be an additional support if we add this tiny thing. And yeah, the build of our RC car is done. Now let's get into the code.
So what you're gonna do is you need to type stemdc.in and it takes you to this page. Sign in with Google, put your Gmail and everything, and you need to sign in. When you sign in, you get this kind of screen, but you won't have any projects here. Instead, it'll be blank. So to start it, or if you have used it before, you may have few, but for the starters, no. And now we need to go to start a new project and type. You can give pretty much any name without spaces because it doesn't accept that. I'm going to give it as RC car. Yeah, and open this type of UI. And what you're going to do is we need to design how our app looks, and that app is gonna function as a remote control for our RC car. First we need to go to connectivity and bring out Bluetooth client. UI, we need 5 buttons: forward, backward, left and right. And another one is stop also. Then we also need a list picker for the Bluetooth connection. We need to go into QtPy mega blocks and search for motor. Yeah, now we need to put 2 motors. Okay, before that, as we can see in the properties, Bluetooth client, we need to add it. Put 1 in any motor and rename again Bluetooth client and 2. So I always use the left motor in port 1, so I'll rename the motor 2 into left motor, and the second port as right motor. We need to change all the text in this. So the button 1 will be functioned as forward. We need to rename this 2 times, and here in text also forward. And pretty much in the same way we need to name everything. Let this be backward. Bluetooth. One, we can design this in a better way. It's gonna be horizontal arrangement. And yeah, I'm gonna put it like this. Right. Let the Bluetooth be on the top, and stop, we can align it in the center. Okay, no, it's the text align, sorry. If you want to make it more better, we can change the text size. Yeah, here. Name it 30 and I'll put the background as transparent. And we can do that for everything. Now let's go into the coding part. We click here and go to blocks and we get this type of screen. So first we need to make sure that our app connects with the motherboard. So scroll down and we can see this Bluetooth list picker. We need to take before picking and after pick. So before picking is like when you click this list picker before picking, it shows the number of device that your mobile can connect through. And first let's finish coding this. We need to take this Bluetooth elements, fix it. There's an error mark because we're not added anything here. We go into the list picker. No, we go into the client, Bluetooth client. Then yeah, Bluetooth client address and names. So this shows all the details of number of devices which we can connect to. Then oh, I forgot one more thing. Here we need to put notifier. These all are non-visible components. That means that when you run this app, these four things won't be visible on your screen. These will act behind the like a backend stuff. After picking, we need to use if then if and else statement. Okay, so I know this. It's this, and just click the blue button and add else. If we need to go to Bluetooth client, if Bluetooth client connects to the address, then the Bluetooth client need to attach it to the selection. If we click the desired device, then we need a notifier to tell us that it has been connected, or if there's a problem we need the notifier to call out the function not connected, and that is show alert notice. We need to go to text, the first one. If this statement happens, then it should show connected. If not connected. Yes, so we are pretty much done with the Bluetooth part. Now let's go to the coding of a DC motors so that our RC car can move. First we need to go to forward and let's take touchdown. So touchdown means that when you're clicking the button or long pressing it until you press a particular function should happen. That's touchdown. And when you're removing your hand from that button, it's called touch up. So forward touchdown, when you touch the forward button, we need both the right and the left motor to move so that it can move front. So let's add the speed. The maximum speed this DC motor can obtain is 255. Same with this. And we need to go to logic and take this true or false statement. True states that the DC motor will rotate forward, and false states that the DC motor will rotate backwards. And touch up, pretty much I guess you guys would have guessed it. When we take our hand out of the button, then it should automatically become 0 or it's just stop. That's the objective here. Now the same thing with backwards. Only thing we need to change the direction. That's going to be false, which is behind. Okay, this for the touch up false doesn't matter a lot. Now let's go to the left touch up. Left. So for a RC car to move left, the left motor should move towards the back and the right motor should move front. Then our RC car can turn towards the left. So for that, the right motor should be true, that'll move front, and the left motor should be false, that'll move back at the same speed. Remember, if you keep at the same speed only, it can move perfectly, or else there'll be some flaws in the movement of the RC car. Now touch up again. It doesn't matter a lot, we can just put it like this, because at the end it's just 0. Now right. And the same logic for the RC car to move right. The right motor should move back and the left motor should move front. And the last part, that is stop. This function is not pretty much useful, but if the DC motor goes out of hand, like even after the touch up, it just continuously moves. In that emergency situation, we can just click stop. That's going to be 0 0 and touchdown. Instead of the touchdown thing, we can go to stop and use the click button. Click is just when you click it once, the DC motor stops. Also, when you keep the touch up and touch down, when you remove your hand, it's going to start moving again. Yes. So yeah, we are pretty much done with the code, and all we need to do is a simulation. I'll explain how to install this in your Android device. So type MIT App Inventor, and yeah, this thing, MIT AI 2 Companion. You need to download this, open this, and give allow to everything. So now we can see that type in the 6-character code or scan the QR code. For us to get the QR code, we need to go back, go to play, then go to designer, and we can see there's something called build and app provide QR code for APK. Click that, and this thing will generate a QR code so that you can scan to the MIT App Inventor. Then it asks you to download the APK and install it. And after installing, you're pretty much done. Now our build and our app is ready. Now all we need to do is the implementation. This is how the QR code looks, and they also provide you with a link. You can download using the link also. Okay, I've already installed my app. Yeah, let's get started.
Now we gotta open our app, and this is how it looks. Then you go into settings and turn on Bluetooth. And click on the Bluetooth list picker, and it'll show you a bunch of Bluetooth devices that you can connect to. But for the video's sake, I have just blurred them all. You can just choose the QPI motherboard, and we're pretty much done. It's connected.